All right, I'm talking about the recent experiments using a nonlinear uh, nonlinear Doppler effect. So normally the Doppler effect is considered in a linear direction of space. So you're moving forward or backwards, but somebody realized that what they call the Penrose process was that with a black hole with a vortex of space-time directly, then if a particle is extracted as it splits, there's energy that's reflected and amplified, so it can be extracted from the black hole due to the negative frequency of reverse time itself. So they couldn't reproduce this because of the rotational speed. When you have a nonlinear Doppler effect, you're converting a forward or backwards direction into a circular radial direction. So the change in the frequency of the energy is now a change in the wavelength as a phase shift, as a rotational speed. So then somebody realized that if you use a cylinder, basically you can visualize this as the energy is reflected off the cylinder, but if the cylinder is going fast enough, then the reflection of energy is actually amplified. But to do this with sound, you're still relying on a linear Doppler effect, and because it's a cylinder that's rotating, so the cylinder has to be a ratio of the wavelength of the frequency of a sound wave, which means that you have to have a super long cylinder because the sound wave, the frequency is lower. So at first they couldn't test it because with light waves the frequency is too high, so they can't rotate something fast enough. But then if it's a cylinder, then it's so the wavelength is too long, so then they just switched to absorbing the energy directly just through a pure not totally nonlinear, just with a circular phase switch change. And so what they found is that when the phase shift of a spiral of sound, when you rotate an absorbing medium, so that it's below 1/4 of the phase shift of the speed of the frequency of the sound, then the frequency keeps going down. But when it hits that 1/4 of phase shift, all of a sudden the frequency disappears and it goes to zero frequency, or it's below 4 hertz frequency. But then it switches due to a amplification of the sound as a negative frequency from as soon as the phase shift in the speed is above 1/4 of the original frequency of the spiral or orbital sound wave. And so then they demonstrated a 30% increase in amplitude energy that's extracted or absorbed due to just having a phase shift that's 1/2 of the frequency. So you're just this, instead of relying on a wavelength, it's just a speed of as the frequency for instead of the phase shift being the wavelength, it's the direct frequency of the original sound. So this experiment is now being replicated with metamaterials, so you're having a complex phase shifts with negative frequencies, and you can do that by having two different light waves that are slightly different frequencies. So then the difference between them is a subharmonic as a lower frequency. So then you can observe the energy change without needing some super fast rotating disk. That's what they call a sub-wavelength metamaterial, because you're getting a negative frequency of the light as like a reversal of the phase of the light. And then so they're working on using this to extract energy, and maybe it's already been used, with secret military technology. But this is what I called the Hempel effect. I didn't know about these other scientists, but the idea being that the phase shift, it's, when you look at it visually, you perceive a change in the frequency, and of course then you can have a Doppler effect or an inverse Doppler effect, which it means that when an object is going away from you, the frequency actually goes up, which is the reverse of the usual Doppler effect. And this again is just based on the relative phase change with whether it's a negative frequency or not. And so the whole idea of non-commutative phase is that the pitch of sound can be the same as a perfect fifth, but because you're changing the phase, even though it's the same pitch as a perfect fifth, then you can actually have an amplification of energy, and you can extract energy just by reversing the time as a phase change. And of course the issue is, in these experiments, first they try to do it with a linear thing, and so this is the same problem, the original problem of tuning an instrument, is if you have a wavelength that's longer than the instrument, then you can't line up the harmonics of the original root tonic, so that you have an octave and a fifth and then the fourth is not a natural overtone, but it's from doubling the fifth as a phase change in the opposite direction. So it's 3/2 as a harmonic, and then it's 2/3 as a perfect fifth as a subharmonic. But obviously if you have a subharmonic, then that's longer. It's a longer wavelength than the actual instrument being used. So so the whole issue here obviously is that if you're listening to sound, you don't need an external instrument, so you're not limited by this constructing a instrument that's has a long enough wavelength within it, or rotating something fast enough so that the frequency is a close enough ratio to the original frequency, so you can amplify the energy as a negative frequency due to the phase change as a resonance that's reverse time. But if you're listening to something as frequency, then the time is period, and you can't see the source of that time. So there's no need to have a external experiment or tool that rotates a spatial instrument relative to something else that's also spatial. So when we measure time as speed or phase or frequency that's normally symmetric and whatever in wavelength, we keep neglecting the fact that time can't be seen, and so we can, just by listening to the natural harmonics, because they're non-commutative, then we resonate the original complementary opposites as a negative frequency and reverse time, not inherently, and so just by turning the light around inside us, then we can listen to the superluminal light as the Penrose process and extract that negative frequency energy directly from the subquantum relativistic ether, if you want to call that, or what De Hooft calls the eternal black hole as a relativistic virtual particle. So this is the asymmetric time that Penrose is referring to. But since one of them approaches it from relativity and the other from quantum physics, then they can't agree on the terminology. But another scientist, Rovelli, he says that dark matter is actually white holes on a sub-Planck level. So we're surrounded by the